Hi, this is Sam Iyer. I'm a cloud analytics architect from Google Cloud. In the previous video, my colleague Mo would have showed you the solution concepts about real-time prediction. So what I'm going to be doing in this video is how to go about deploying a real-time prediction pipeline. So I'm going to walk you through the demo. I'm going to have two pieces in the demo. One is the actual GitHub repository that kind of goes step by step on how to go about deploying the solution. While I read through it, I'll also have another screen on the side that actually shows my GCP project where I'll actually be walking through the steps on how to go about deploying the pipeline. So with that, let's get started with the demo. I'm going to present my screen again. So here we go. So on the right over here, I do have this entire solution deployed in a GitHub repository. So what you can do is you can walk through step by step on how you want to go about deploying this in your own project. But at least let's talk about a high-level overview, right? So what does this real-time prediction solution do? So this lab actually predicts if a flight would arrive on time, and what it does is it uses historical data from the US Bureau of Transportation and Statistics. And what happens with this website is there are major US carriers who are actually required to file statistics about their domestic flights. They need to report information about a flight departure, flight arrival, what was the actual departure, what was the actual arrival time. So it kind of captures all this information and it's actually sent over to BTS. And what I've done in this demo is I'm actually downloading that flight on-time performance data from BTS. I'm actually storing it in a cloud storage bucket. From here, I would probably be moving something to BigQuery. Some of these data sets that I want to create out of these flat files I got in this cloud storage bucket. And then from here, what I'm going to be doing is I'm actually going to be building some training and validation data sets. That is going to be used by a Vertex AI model to help me with prediction to let me know if a flight can arrive on time or not, depending on the origin and destination of the flight and time of the day when the flight is actually going to be flying. So down at the bottom is where I'm actually simulating flight takeoffs and landings. So what happens in here is I do have a subtopic that is going to be simulating a bunch of events. And these streaming events are actually going to be captured by data flow. And what data flow would do is it'll call the Vertex AI model that I have deployed, and then it's going to publish the predictions to BigQuery. So I've kind of walked through all the high-level steps on how to go about deploying this model. So if you see in here, I'm actually ingesting flight on-time performance data. Some of these variables here like date, flight times, origin, so on and so forth. Then I'm also going to get like some airport information. So what is the airport code, what city is in, what's the lat long of this airport as well. And then what happens is I stored like standardized and transform data sets in BigQuery. So that's what happened when I showed you the architecture up there. Then beyond that, what I'm going to be doing is I'm going to be doing some model training, and then I'm going to be doing some prediction, right? So what, like I said, what are all the inputs I'm trying to get from the BTS website? I'm getting airport information, I'm getting raw flights data. I'm actually transforming this information to correct it for like time zones, meaning I just want all the time zones to be in UTC. Then I'm actually going to have some simulated flight events as well. And the output is actually going to go to the streaming preds table within my BigQuery data. So let's get started, right? So what are we going to do here? So if I walk through, sorry, I got out of there. Let me go back to the right solution here. So I'm going to walk through step number one. So step number one, actually, I'm going to have a GCP project, which I already have. And I'm going to be opening Cloud Shell or open Cloud Shell. The first thing I would do is actually clone this GitHub repository where I have the code. So that's what this is about. So if you see in here, I'm going to clone this, but I've already cloned this information before. So I do have the repository cloned to this GCP project. So if you see in here, I do have all the information that I need. So let me go to the directory where I have the solution. So if you see in here, I do have some code in here that talks about various things I need to do. So as the first step is what I want to do is I want to set up the environment. So what happens with this script? So when I run the script, essentially it's going to create some project variables. It's going to enable some necessary APIs for the services I'm going to be using. For example, PubSub, Dataflow, Vertex AI, BigQuery, so on and so forth. It's going to add the necessary roles for the default compute service account. Plus, it's also going to be creating default networks and subnetworks and some firewall rules as well. I've already run this on mine, so I already have all these variables set up. I have the networks defined and everything. So the next thing you probably want to do is, okay, I want to get the data for this project. So that's what this next step in the script does. So what this does is it actually it's going to reach out to the BTS website and it's going to download a bunch of information. So what I've done is I've already run the script. I've actually created a bucket for it, and I've downloaded a bunch of files from the website. So if you see in here, all this is what is being downloaded from the BTS website. So once that is downloaded, I've given you instruction how to go about validating it. So anything that's starting with flights or the information that I'm getting dumps from. So just validate it within your environment to make sure these files are showing up in the bucket. And then I've also given you the count. Say, for example, I have like sim events, I have about like 5 files. Flight folder, I have like 3 subfolders in there. So just go about the step by step to make sure the data is being downloaded properly and you have all the data available. Once that is there, what happens next? I'm actually going to be loading some of this information to BigQuery. So that's already happened. So if you go to BigQuery and if you look up what's in there, you would probably see. Hold on a sec. Where is BigQuery here? Here. So in here, you're probably going to see a data set. And then within the data set, you're probably going to see some of the files. The tables within the data set. I do have like 2 data sets. One is a flights data set, another one is a train data set. So within flights, I do have a bunch of tables I'm using. Within train, there's a bunch of tables that are getting created. All this will be created at different stages when you follow the GitHub repository in here. So initially what I've done is I've actually downloaded the file. I've created some of the tables within BigQuery. That's done. And then beyond that, what I need to do is I need to make sure I do have some org policies set up properly so that I can run other downstream processes that I need to run. So in this case, from a compute standpoint, I need to make sure this required shielded VM is turned off. So I actually walk you through some of the steps. I'm also making sure we can have visibility to external IP. I want to make sure that policy is also turned on. So that way, what I can do is I can make sure I can have these VMs visible as external IPs. So once I have that done, the first thing I want to do is I probably want to install some packages, and these packages are pretty much to run some TensorFlow and Apache Beam processes. So that's what that script does. Kick off the script, and it's going to install all the packages that's necessary for you. Once we have that, then the first thing I want to do is I actually want to go train. I actually want to prepare some data sets for training purposes. So that is what this next step does. So when I kick off the script where it says create train data.sh, it is actually going to kick off a train data flow batch job. So let me go to data flow and let me show you how that looks like. So if I go to jobs, I do see this train data batch job in here. So if I open up this job, it's going to go through a bunch of steps, right? And what it's doing is it's actually creating training data sets that's going to be used by my Vertex AI model. So that's what this batch job does. Again, I've given you a snapshot of how the batch job is structured. Once this is through, what happens is it's a train folder, and it'll actually create a bunch of, it's got a bunch of files in there that is going to be used for training needs. So coming down, so it's actually created some training CSV, some testing CSVs, and some validation CSV files as well. So you can make sure that it creates a staging folder and temp folder, and make sure these files are available there. So gotta go check your bucket to make sure these files are available. Once that is done, then what I'm going to do is I'm going to kick off the train model shell script. So what does this train model shell script do? It is actually going to be training a custom Vertex AI model, and then it is going to send the training data that I've generated in the previous step, so that it can train the model, and then we can use this model to go predict when a flight would be on time. So let me go to Vertex AI, and if you go to Vertex AI, go have a look at training. And if you look at training, so here's my training model. I've actually finished training. So initially, when you run this, it'll probably take about 15 to 20 minutes to train. So leave it running and make sure it's finished. So once it's finished, what you would see in here is you would actually see where it's actually deployed. So what happens in here is it's deploying this flights endpoint. So this is my Vertex AI endpoint, what that I'm going to be calling from data flow, and I'm going to be providing some data so that it can predict if a flight is going to be arriving on time or not. Now I'm actually gone through this step. I've actually done this. I've showed you this, how to deploy the endpoint. Now the last step would be is what do I do to simulate some of these flights, right? So this is where what I'm going to be doing is I do have a script that is actually going to be simulating flight takeoffs and landings. And then I'm going to have another script that's actually going to be running through to predict the arrival of these flights. So let me at least start off the script. Let me copy this guy. Go here. I'm going to start the script off. Authorized my Cloud Shell. And if you see in here, just give it a second or so. What it'll do is it'll start sending out some events. And these are nothing but, hold on, something is going on here. Let me reconnect. Cloud Shell is kind of little finicky now. It is. Let us make sure it actually can provision the Cloud Shell instance again. Not sure why it's doing this, but anyway, what is going to happen right now is I probably need to kick off the shell script again. So what will happen in here is it is going to simulate some of these events. So it's going to simulate an arrival or a departure or a takeoff. So arrived is when the flight has actually landed. Departure is when it's actually left the gate. Wheels off a side when it actually took off. So that is what this PubSub event is going to show you. Once that is generated, then what happens is it actually creates these three topics behind the scenes. The script does all that. And then it'll start spitting out each of these events. And then what I would do is I would go kick off this predict flight search script. And what this script does is it is actually going to create a streaming data flow job. And what that streaming data flow job will do is it'll go read these subscriptions from the topics. And then what it'll do is it'll call my model, and the model is actually going to spit out a prediction saying if a flight is going to be on time or not, or if it's on time, what's going to be the probability. I'm not sure what's happening with my Cloud Shell again. I'm going to shut this off and restart it again. Just give it a minute. All right, while that is going on, let me actually show you what could be happening. Let's say the simulation is actually going on. It's actually going to be sending out some events. And what would happen is those events would actually be read by data flow. And let me go to data flow, go to jobs. Oh, by the way, I got this back. So let's go simulate flights. Okay, I need to be in the right directory. All right, let's authorize the Cloud Shell. Give it a sec. Now you should see these flight simulations come through. It's actually running through to make sure if it's got these topics. You already have it now. If you see in here, it's talking about all these simulations. Let's say if you see here, it's got wheels off, something says drive or departed, something says arrived. So it's publishing a bunch of events. So since I have this event going on, I do have the streaming pipeline. And what the streaming pipeline does is it's actually reading these events, and then it's going to be calling the Vertex AI model that I have, and then it's going to pretty much predict what if the flight is going to arrive on time or not, and then it's going to write the results to BigQuery. So leave it running for some time, and then what I would suggest is go to BigQuery, and then in BigQuery, open up the data set where I'm going to have the streaming PREDS table. So if you scroll down, if you open up flights, I do see the streaming PREDS table in here. So what's happening in here is I'm actually capturing the event time, which would be the time that you see in here. It's going to calculate, or it's going to predict the probability on time. It's also going to take into account the departure delay, if it has any, what is the taxi out time, the distance flown, and then it's also going to capture the origin and destination airports. Beyond this, the other things it talks about, like departure hour. It says, is it a weekday when the flight was flown, which carrier was operating this flight, lat long of the airport, departure airport, lat long of the arrival airport, what is the average delay and what's the average taxi out. So if I show you a preview of this table, so this is how it looks. And then this column that you see in here, where it says prob on time. So here it's actually saying this flight is probably got like a 50% chance of arriving on time. And it's basing all that on average departure delay, so average taxi out time, the distance flown, what is the origin city, destination city, the departure hour, what time of the day or what hour of the day did the flight depart? Was it a weekday? And what airline was actually operating this flight? So that is what this whole model does. What you could do from here is you could probably put a Looker Studio dashboard on top of this and at least look at trends that's happening over time. Again, keep in mind, though, this is more of a real-time prediction model based on airline stats. So one good use case is we can probably show somebody like an airline customer who we may have on how to improve their customer sat scores, show them how they can predict if a flight would arrive or depart on time. Number one, they can manage schedules. Number two, they can make sure the customers are well informed. Few things they could do. So what you could do is you could pretty much reuse the same framework for other streaming predictive use cases you may have. I've kind of given you the platform and the tool sets in here, but if you have to reuse this for another model, it's all a question of you developing your own model for that, redoing the data sets for this, but you can still leverage pieces and components within this solution to go build your own real-time prediction solution. Again, I hope I went through all the details. If you have any questions, feel free to reach out. Thank you very much for taking the time, and have a nice day.